Okay, so on the front of your note packet, I made a little thing that I was hoping would be like your one-stop shop for formulas. Okay, so I put every type of formula here, every shape, and so every time you look at this, if you need all your formulas in one spot, they're all in one spot. Okay, so what I mean by sketch is I literally want you to sketch what those shapes look like. So parallelograms. Looks like this, right? Some of them. Some of the parallelograms also are either a rectangle or a square. So we have a lot of different types of parallelograms. It's either slanted, it's a square, or it's a rectangle, but in the end, this side, the top and the bottom are always the same, and the side are all the same. Okay, and the formula for this area is equal to just base times height. Okay, now in a triangle, you can have a couple different types of triangles. You can have a right triangle, or you can have not right triangles. Or you can have an equilateral triangle. Lots of different triangles, as long as they have how many sides? 3. The formula for this is 1/2 times base times height. Or, if you're one of those people, you can write it as base times height divided by 2. I'm this kind of person. Okay, the bad part about this is, that's not formulas. We got that. Multiply two numbers, divide by 2. That's fine. The difficult part is solving for all the different sides that we don't have. And remembering our 30, 60, 90, and 45, 45, 90 special right triangles. That's the difficult part. Y'all got this in the bag. Okay? But, believe it or not, the stuff we've already learned, we're going to use it again. Wow. We all here today. Because I always do, just in case people want to rewatch it, or first period. I record during second period, so I get all my
PBGBs out.
Yeah. Sure. Okay. So first of all, we're just going to start with parallelograms. So go down here to 1A and 1B. So let's find the perimeter and the area of each parallelogram. So in this example 1A, we need the height. Because remember, in all of these, whenever you're using the height, it has to be the up and down height, not the slanted height. So we have to find this height in order to find the area. Okay, so knowing what you see, you have a right triangle, you have two sides. What is the best option for us to use? Pythagorean theorem. So you would have 8 squared plus x squared equals 17 squared. So what does your height become?
15.
Yes, I got 15 for the height. Okay, let's talk about all the other pieces we have. We have this up here is 21. So if this is 21, what's this bottom piece? 21 as well. And if this is 17, what's this side? 17. Everything I just wrote in green makes the what? Perimeter. So to find the perimeter, 21 plus 21 plus 17 plus 17. 76 centimeters. Okay, now the height that is written in purple, along with the base that I just reboxed in purple, that helps us find the area. So the area is base times height. Your base is what? 21, and your height is?
15.
Thank you, Kalia. Is everyone else out there with us? Yes.
315 squared.
Huh?
315 centimeters squared.
315 centimeters squared. Thanks.
I got to that.
That's for triangle.
Oh, yeah.
Thank you. Okay. Good?
Mm-hmm.
Okay, 1B. What can I find right now without solving for anything? I can find the area. Right? So, let's go ahead and do the area. Huh? Zach, what is the base and the height of this parallelogram? 23 and 24. Good. Multiply those two numbers together, you will have the area. If you don't put your units in squared, I am going to take off points. I hate taking off points for that, but you have to. Okay, what am I missing?
The other side.
The other side. I know this base is 23, which means the top is 23, but I don't have the slanted side. That's what that's called. It's called the slanted side. So I need to use what to find it? Pythagorean theorem. 24 squared plus 7 squared equals x squared. Take the square root of that. Oh, wait. I got 25. So for the perimeter, who next? Abby. What four sides do I add together to find the perimeter? 23, 23, 25, 25. Which is going to be 100 and something. Oh, man, I was close. 96 feet. Flip to the back. So in those two examples, we have used Pythagorean theorem. In these two examples, what kind of triangles do we have? 45, 45, 90, and 30, 60, 90. Would you like a review of these? Especially 30, yeah. Okay, so let's go to the top where there's some extra room. I'm going to go right here. Okay, and let's talk real quick. This is going to be 45, 45, 90 triangle. Okay, if this is x and this is x, then what's your hypotenuse? X square root of 2. Okay, we need to talk about a scenario that you're going to use quite often. Example, draw another 45, 45, 90 triangle. Okay, so in the case that, I'm not going to write this because I just want us to talk about it. What if, instead of writing 10, this was 10 square root of 2? What would your legs be? Just 10 and 10, right? Let me say that again. If this was 10 square root of 2, then the leg would just be 10 and 10. Because if this is 5 and this is 5, then that's 5 root 2. Okay? The case that is a little bit tricky and that we sometimes struggle with is the case where there's no square root of 2. So what has to happen, if you want to find the leg and you're given 10, aka the hypotenuse, you have to take the hypotenuse, square root of 2, divided by 2, and that's how you find your leg. So a generic formula for this would be x equals hypotenuse square root of 2 divided by 2. You have to use this whenever you're given the hypotenuse and no square root of 2. Do y'all remember that? Okay, then let's do 30, 60, 90. 30's at top. Okay, the leg across from the 30 degree, what did we call that? S for small side. Okay, we always want to get the small side first, right? That one's the easiest for us. So after we have the small, if we want the hypotenuse, we do S times 2 or 2 times S. Your small times 2. And then we called this other side, we called it leg because it was across from 60. And if you want to find your leg, you always take your small and multiply it by root 3. The scenario you're going to run into a lot in this lesson is you're going to have the hypotenuse and need small. So that's a good scenario, right? Because if we have the hypotenuse and you need small, you just divide by 2. Okay, y'all feel better? You got it in your head? Okay, let's look at 2a. Find the area. Notice that. We're only having to find the area of each parallelogram. Okay, well, if this is 9, what's the height? 9. That one wasn't bad, right? So area is equal to,
153.
did you do 17 times 9? Which is 153. Yards.
Squared.
Good. Bye, Jasmine. Okay. 2b. What are you given in the small triangle?
No,
The small. You're given the small. Do I need the hypotenuse? I'm just finding area. I have the base, and I need the height. So I need the L. So if I have small, how do I find L? 12 root 3. So the area of this is going to be base, which is 32, times 12 square root of 3. Round to the nearest tenth, so I got 665.1. Okay, how many of you did not get that? Okay, remember, if you're using the calculator like Lakeland and Christian, if you're using this calculator and you plug in your square root, remember it opens that parenthesis. So if, for example, on this one, if you put 12 first and then 3 times 32 and you didn't close that parenthesis, it's going to give you something funky. So remember, you're always closing this parenthesis right here. That one. That's what I was talking about. Okay? Okay, I want you to do 1 through 6. And then finding the perimeter and the area. So I'm going to pause for a few minutes and give y'all a little while to do 1 through 6. Okay, so let's talk about these. The most difficult ones were 2 and 4. Were the two that were supposed to be the most difficult. Number 1, to find the perimeter, this was 8 and this was 10, but you had to add them together. So it was 18 and 18. And then to find this side, you had to use Pythagorean theorem, which I got this side was 17.9. So for the perimeter, you add up all the sides. For the area, you have to do base, which is 8 plus 10 times 16. Questions on 1? Okay, 2. First of all, they're all congruent sides. So all the sides are 24. So the side you had to find was this height. Okay, well, one property of a parallelogram is that if this angle is 60, so is this angle, which made this 60, 60, 90, and this one would be 30. So you had the hypotenuse, and you needed to get to the leg. But the easiest way to get to the leg is to find the short first, which made this side 12, right? Divided by 2. And so your height was 12 square root of 3. So for the perimeter, 24 times 4. For the area, 24 times 12 square root of 3. Okay, for 3, this is the easy case, right? They're all the same. 1.6 times 4 gives you the perimeter. 1.6 times 1.6 gives you the area. Good? Number 4, you had everything you needed. To find the perimeter, 20, 20, 10, and 10. To find the area, base times height, 20 times 8.
So why was that one of the hard ones?
Oh, I meant 5. Sorry, 2 and 5. 5. It wasn't necessarily hard if you remembered if this is 45, so is this. And that makes this 45 as well. So you have the hypotenuse and you have to find the legs. This is the case I talked about earlier, right? To find the leg, you can't just put 15 here. You have to do 15 square root of 2 divided by 2 to get your height. I got that to be 10.6. So then perimeter is 30, 30, 15, and 15. Area is 30 times 10.6. And then 6, those were the same as number 3. Good? Yes?
I find the 2 legs a difficult way.
How do you do it?
I do like substitution with Pythagorean theorem where I do x squared plus x squared equals 15 squared.
So 2x squared, and then you divide by 10 fixed square root. It's pretty cool. Okay, to the back. Now we're going to do triangles. So you're going to have to get in your mindset to divide by 2 triangles. Okay, now, triangles, do you see the shaded portion? Do you see the shaded portion and the not shaded portion? You're only finding the area and perimeter of the shaded portion. The other sides are there to help you find missing pieces. For example, this one has how many missing pieces? 2. You have to find the height and this side. So, in order to find the perimeter, you have to find both of those. In order to find the area, you only need one. So, the first thing I would do is find the height, which is going to be x squared plus 3 squared equals 5 squared. Or, it's a triple, so you know it has to be 4. So, the height is 4. So, now to find the hypotenuse of the big triangle, this is a 90-degree angle, so you would do 15 squared plus 4 squared, and that's going to give you this leg. Take the square root. So I found that this is 15.5. Okay, so perimeter, add up what 3 sides? Huh? 15.5 plus which is 34.5. Area, what's the base? 15. What's the height? And then multiply that by 1/2 or divide it by 2, whatever you want to do. 15 times, I do 15 times 4 times 0.5. And you get 30 centimeters squared. Okay, try 2. How many pieces do we have missing in number 2? Just 1. Can I use Pythagorean theorem? Can I use Pythagorean theorem? Yes, to find this piece right here. What's your base for the area? 20. And what's the height? Your height has to be the one that's straight up and down. So the height is not 17.88. The height is 16. Okay, try 3. Questions on 3? Okay, there's a scenario in number 4 that we need to talk about, just because you haven't seen it yet. Okay, how many pieces am I missing in number 4? 2. However, first of all, we need to find this piece. Well, if that's 9 and this is 9, then this is 9 root 2. Okay, so this is 9 square root of 2. Okay, how do I find the other piece? Because this shaded portion is not a right triangle.
Use the entire thing.
Right. Okay, so to find this piece, you have to use the entire right triangle. So this side's 9, that stays the same. But in order to use this side in Pythagorean theorem, you have to do 13 plus 9. Does that make sense? Because it's 2 triangles, but when you put it all together, this side is still going to be the exact same for this triangle and the big triangle. So in order to find this piece, you're going to have to do 9 squared plus 13 plus 9, which is 22. 22 squared equals c squared, or x squared.
So do you use the whole triangle to find everything else, or just for that?
Just for that. Okay, so I take the square root of that, and I found that this is 23.77. Okay, so now to find the perimeter, what 3 sides do I add together? 13 plus 9 root 2 plus 23.77. Which is 49.5 centimeters. Okay, what do I do for the area? What's your base? 13. What's your height? 9. 9 is your height. So you get 58.5 centimeters squared. Okay, we're going to skip 5 and 6 for right now. If you've already done it, that's fine. But if you look on the next page, page 4, I want you to finish 1 through 6. 1 through 6. And then we didn't get all the way finished. There's, I want to get to 7 and 8. So we'll come back and do those tomorrow. Okay, 1 through 6 on page 4.